After the unavoidable delay due to financial overruns and great anticipation from tech enthusiasts, the James Webb Space Telescope, or JWST, has finally launched. Set to begin its mission in mid-2022, the Space Telescope will most likely unravel some of the universe's unanswered questions. Want to know more? Stay tuned to the end as we tell you all about the latest space news. NASA's James Webb Space Telescope, a successor to the famed Hubble telescope, was launched on December 25, 2021, on an assignment to study the first stars and peek farther back into the universe's history than ever before. It appears things are about to kick off. Are you ready? Information gathered by JWST is essential to enable humans to comprehend the universe's past and establish its large-scale structure. Understanding how stars and planetary systems originate is the third pillar of JWST research, allowing us to compare our solar system to countless others around the cosmos. Astronomers will be able to utilize JWST to investigate the dark matter composition and movement of distant galaxies, which might help to answer the puzzle of how rapidly the universe is expanding and what its destination may be. Finally, JWST will point to exoplanets orbiting distant stars to peer through their atmospheres for signs of alien life. Webb is no doubt the most powerful and giant space telescope ever launched, as it is now monitoring Lagrange Point 2, or L2, about 1.6 million kilometers away. During its production, the gigantic telescope was folded strategically to fit into the rocket that launched it, so it could slowly unfold during its first week in orbit. Its massive mirror, composed of 18 gold-plated beryllium hexagons, will expand. The 5 razor-thin aluminum-coated layers of a specialized polymer film called Kapton will act as a screen to filter light from the Sun, Earth, and Moon to keep the telescope cool. A massive kite-shaped screen shields the James Webb Space Telescope from the Sun's and Earth's heat. Research proved that the heat received and re-radiated by the observatory would be enough to destroy its images of the cosmos without this barrier. So here is the plan. After launching an Ariane 5 rocket from French Guiana at 12:20 p.m. GMT, the spacecraft will proceed to a gravitationally stable region known as Lagrange Point, or L2. It circles the Sun 1.5 million kilometers beyond Earth. This distance from the Sun will guarantee that the onboard equipment JWST stays cool, as this is a necessity to acquire quality photos. On April 13, 2022, JWST met an important temperature milestone. The Mid-Infrared Instrument, or MIRI, on the James Webb Space Telescope has attained the super cold temperature required for proper operation. The milestone has been accomplished following a rigorous and meticulous cooling procedure, according to NASA. Because the sensor is designed to detect infrared light, which appears as heat, the temperature must be kept below -447 degrees Fahrenheit, comparable to -266 degrees Celsius. On Monday, the 9th of May of 2022, NASA updated the James Webb Space Telescope's commissioning, highlighting a test picture captured by its Mid-Infrared Instrument, or MIRI. The new photo, which shows a portion of the nearby Large Magellanic Cloud galaxy, was compared to one obtained by NASA's earlier infrared telescope, the now-retired Spitzer Space Telescope. The JWST's operators will test the numerous electronics and scientific equipment as soon as the telescope is wholly erected. It will begin its scientific mission assuming everything goes well. The operators will continue calibrating its sensors for another 5 months on average. What's more, JWST is currently in the middle of commissioning. However, the process is built on 4 fundamental pillars, and it addresses many of astronomy's most critical issues. To achieve these aims, it will observe infrared frequencies, avoiding the visible and ultraviolet radiation that the Hubble Space Telescope uses. Its massive mirror will let it observe things 10 to 100 times fainter than what Hubble can see, and, in detail, 10 times more exact. For all it's worth, NASA has made all arrangements to provide an update on Webb's final prep stages. The 3-month process of aligning the James Webb Space Telescope sensors and mirrors is now complete. According to a report on April 28, 2022, JWST is completely aligned and the views are outstanding. NASA's James Webb Space Telescope can now take crisp photographs of astronomical objects using numerous sensors. The government released sample photographs that, although modest, illustrate the instrument's excellent focus and provide a tantalizing glimpse of what's to come. Speaking of new innovations, did you know that Dream Chaser, the new generation spaceplane, recently showed off its new wings? We bet you haven't. Dream Chaser is an American reusable lifting body spaceplane built by Sierra Nevada Corporation or SNC Space Systems. Envisioned initially to carry personnel and cargo to low Earth orbit locations such as the International Space Station, the vehicle is designed for high reusability, lowering overall costs, and quick turnaround between missions. Dream Chaser's ability to launch on top of multiple launch vehicles and land on various runways makes it a versatile option for dependable transportation. The Dream Chaser space system will be developed as a crewed spacecraft once the cargo counterpart, Dream Chaser Cargo System, is operational. The crewed version is designed to transport up to 7 passengers and cargo to and from low Earth orbit. Dream Chaser will perform at least 6 freight trips to and from the space station, transporting crucial supplies like food, water, and scientific experiments before returning to Earth with a smooth runway landing. It will launch vertically on the Vulcan Centaur rocket and land horizontally on ordinary runways autonomously. ESA's suggested version would use an Arianespace spacecraft to launch. Under the Commercial Resupply Service 2 contract, NASA chose Dream Chaser to perform cargo delivery, return, and disposal services for the space station. Tenacity, the first Dream Chaser, just completed structural testing and is now being outfitted with its thermal protection system and other components before being shipped to NASA's Neil Armstrong Test Facility in Ohio for more testing. After leaving the station, the Dream Chaser Cargo System provides disposal services via the Shooting Star transport vehicle. Shooting Star burns up in the Earth's atmosphere after being separated from the Dream Chaser. This is anticipated to occur in August or September, with the thermal vacuum testing taking 4 months to complete. The first operational Dream Chaser will be utilized for NASA's commercial resupply services under a contract won by Sierra in 2016. It will launch uncrewed around a year from now. Sierra claims to be working on a rough prototype of the space aircraft, which might be ready for launch by 2026. This will be crucial for Sierra's ambition to become a Dream Chaser. To test a new method of recovering a rocket's first stage booster from mid-air, Rocket Lab has delayed its next mission by nearly 2 weeks. Rocket Lab's claimed, just as our launch weather tolerances have increased over time, so will our recovery weather tolerance. For this first one, we want to focus solely on the catch and supporting operations. Due to the calm seas, Rocket Lab will now use a helicopter to recover the 39-foot or 12-meter carbon fiber booster stage and return it to an onshore facility for inspection. The company initially planned for the helicopter to ferry the rocket back to shore with the booster suspended underneath it. The Electron rocket will deliver 34 small satellites from commercial operators Alba Orbital, Asterix Aeronautics, Aurora Propulsion Technologies, eSpace, Unseen Labs, and Swarm Technologies. Rocket Lab wants to reuse Electron boosters, reducing pressure on the company's factories to sustain a higher launch rate. The Electron is sized to move small payloads into orbit. Rocket Lab is laboring on a heavier next-generation rocket that will be primarily reusable. While the rocket's second stage and kick stage continues into orbit with the commercial payloads, the booster will arc to an apogee, or peak altitude, then re-enter the atmosphere for a scorching hot descent. Rocket Lab has now added a new shiny thermal coating to the booster's carbon fiber airframe to better protect it from re-entry heating. The mid-air recovery also eradicates the need for the booster to hold a fuel reserve to achieve a propulsive landing like SpaceX's Falcon 9 booster, which offers payload lift capability to return to Earth intact. The CEO of SpaceX, Elon Musk, says that a new engine costs half as much to build as the previous version while also being more reliable and more powerful. There's no limit to what the giant space company can achieve. That we know for a fact, as SpaceX recently launched and landed the same Falcon 9 booster twice in 3 weeks, shattering their current orbital class rocket turnaround record. Just 21 days and 6 hours earlier, booster B1062 completed an almost identical launch with a similar payload of 53 Starlink satellites, shattering Falcon 9's previous 27-day record by nearly 25%. The new 21-day turnaround record is made even more impressive because it took 4.5 days to tow B0162 almost 700 kilometers or 430 miles back to port before it could start preparing for Starlink 4-16. In theory, if B1062 had been able to land back at Cape Canaveral after Starlink 414, SpaceX could have turned it around in just 16.5 days. The previous record was also set by a Falcon 9 in early 2021, when booster B1060 launched a batch of Starlink spacecraft and Turkish communication satellite just 27 days and 4 hours apart. Just under 15 months after, a new Falcon 9 booster has firmly taken the top spot. SpaceX says that refurbishing Falcon 9 B1062 took just 9 days, an extraordinary feat that further indicates that the exact turnaround time is already much lower than 21 days. On the other hand, China launched 5 satellites into orbit on a rocket that rose from a platform at sea on Saturday, April 30th, establishing a new distance record for the country's offshore launches. A long March 11 solid-fueled rocket successfully launched from an offshore platform in the East Chinese Sea to transport its cargo into orbit. The 5 satellites launched by the Long on March 11th will primarily offer commercial remote sensing services for businesses, including land census, urban development, and natural catastrophe monitoring, according to CCTV. It was the Chinese National Space Administration's second launch in as many days, after the launch of 2 additional satellites from a land-based spaceport on Friday. The 2 satellites will provide commercial remote sensing data services for domestic industries such as natural resources, surveying and mapping, marine and environmental protection, and emerging markets such as urban security and digital rural development, China's state-run CCTV news channel reported. China's sea launch on Saturday was the country's furthest offshore liftoff so far. It was the 3rd maritime launch for the nation, which has launched Long March 11 rockets from its Debo 3 platform since 2020. According to Space News, the mission was supposed to launch on Friday, April 29th, but was postponed due to weather. It followed a Long March 2 sea rocket launch from Jiuquan Satellite Launch Center on land, which sent 2 remote sensing satellites into orbit. Would you agree that SpaceX has made significant changes in the tech industry? Let us know your thoughts in the comment section. Stay tuned to our channel for more updates of space news coming your way soon.